Where are you going? You just told me I have to start. Are we ready? Who's the first?
I won't close my eyes tonight, feeling too ecstatic to end the night. I'm living my life from dusk till dawn, ready for another sun to rise. Floating on sensual island vibes, with steaming dreams and flying high. I'm still standing in all my glory. I'm loving these bariatric mornings.
Okay, ladies and gentlemen. Okay, so networking is really happening. Can we postpone that exciting conversations to lunchtime? Can you take your seats, please? Ladies and gentlemen. Well, somebody did tell me I look like a school mom this morning with my buttoned up colour. So I'm just doing my chairing role. So exciting to see the conversations that are happening, but I think you'll be even more excited to hear the next presentation. And let me take the opportunity to introduce Adam Woodley, founder and CEO of Sinewave Energy Solutions, because he's going to say how ICPs fit into the EV space, scaling and standardising grid connections for electric vehicle rollouts. Thank you. All yours.
Thank you. So I am going to be talking about scaling and standardising grid connections for EV rollouts, which I realise is a bit of a mouthful now I'm saying it. That's essentially looking at our experience within the EV space, how we've standardised grid connections for multiple rollouts, and what that looks like for different types of projects that we work on. So I originally started my time in the electricity sector in 2009 working for SSE, one of the DNOs in the UK. I've seen massive transition from when I started within the sector to where we are today, from low carbon technologies. I founded Sinewave in 2015, and we essentially design, install and maintain electricity networks from 400 volts up to 132,000 volts. We work in four main sectors. So the EV charge, which is obviously what we're all here to talk about today. The residential space, so getting new homes and new housing estates connected to the grid. The renewable space, so battery storage, large-scale solar and wind. The industrial and commercial space, so data centres and large sheds. And we are an independent connections provider. Now, what that means is we are an alternative choice to the DNO. So when you are connecting to the grid, you have a choice of going to the DNO to get your connections, or you can have an independent connections provider to provide those services. We notably also have around 2,000 sites under contract for maintenance of HV and LV assets. So we have a whole O&M business. So we really do have a holistic view of networks and the way that they operate across the UK. We started our time in the EV space in 2016, primarily starting on rapid charger projects. And as the years have evolved, we've also evolved with it, from working on projects now up to 350 kilowatts. We work with a number of major players within the EV space, from motor fuel groups to TSG to Instavolt and Osprey. So we really see a huge scale of projects in different sectors. So the typical projects that we work on are from around the 8,000 mark to £3 million mark, depending on what size of infrastructure that we're working on. And these can be from both the on-site works, but also the grid connection works that go with that. And to date, we've completed over 1,000 EV projects. So we do really have a huge amount of experience in this space, both from the on-site delivery and installing the chargers for the CPOs, but also for doing the grid works for all of these projects. Enough about us. What I'm looking to talk about is primarily around new grid connections. So this is not where there's existing capacity. This is where we're looking at putting new infrastructure in. And how you can have partnerships with the DNO, IDNOs, and ICPs to maximize the efficiencies of your rollout and really look at scaling them up. I've then split this into three main categories, which is where we're seeing the majority of the rollouts kind of fit into. There are going to be some that don't necessarily fit into this, but this is where the majority of our work is being found. So that's in small EV connections, hubs, forecourts, and also bus and large power sites. So a new grid connection is required when there is either not enough capacity in the existing network, or it's where you've got a new location solely for an EV charging station. Typically, you'll go to the DNOs for these point of connections applications, and the works will be split into contestable and non-contestable works. The contestable works being the element that an ICP can build on behalf of a DNO and have it adopted, or an IDNO adopt it alternatively. And the non-contestable works being the works that only the DNO can carry out themselves. So in the UK, you've got 8 DNOs across the UK, and by default, they're the electricity network that will adopt these assets. They're the only party to carry out the non-contestable works, and in each license area, they all carry out their works ever so slightly differently. So there's not working with one DNO is not going to be the same experience as working with every DNO. You're going to have different design standards. You're going to have different ways they communicate. And each DNO is typically regionalized as well into different regions, into different depots. So every DNO, you may have a different experience, even if you're working with the same DNO in that space. So when you're looking at mass rollout and when you're looking at large scale rollout, you really want to be working with the same people to be and get the same result on every single time. So the DNOs are incredibly good at what they do, but for when you're looking at large scale rollout, it makes it really, really hard to work on projects like this. And one other note, there's minor design details as well. We're working with DNOs, you're limited to capacity with substations before having to go to HV meter supplies. So for a 1 MVA power for 1 MVA substation, they will typically look at a package substation. Anything over that, you'll then have to start looking at HV meter supplies. And when you're working on large scale rollouts and when you're working on sites that have a really small amount of space in them, you're having to put in additional assets that you wouldn't have to do on other sites. And it also means that you've then got additional assets that you've got to maintain as a customer as soon as you start installing private network transformers, and it opens a whole other field of things to look at. And this is where working with an IDNO, which is a partner for every ICP and a partner for any CPO out there to help standardize the processes. An IDNO can work in any license area within the UK, and their design standards can be nationally used on every single site. So what this means is, instead of having a different plinth design, a different GRP, a different transformer selection, and all these different standards that you need to follow, you can now start looking at a standardized approach across the UK. You can also look at standardizing legal processes. And I also mentioned about the package substation arrangement. So where you're looking at a substation that is over 1 MVA, you now don't need to put in this additional metering substation. An IDNO will allow you to adopt up to 2 MVA. So something like a petrol forecourt, where they're typically looking at 1.5 to 2 MVA power consumption, means that you've now got a greater amount of power, but a smaller amount of footprint on site. There's also a CAPEX and OPEX reduction to the customer as well. The DNO by default gets that electricity network if you go with them to install it. An IDNO will essentially bid for this asset. They are looking to get long-term revenue out of the charges that go through the meter. So they are giving you a capital contribution towards the project, which you can then offset on your projects. There's also an OPEX reduction as well. So when I'm talking about the 11 kV package substations up to 1 MVA, if you go over that point, you've then got this HV asset, or the CPO or the customer on site has this asset that they've then got to maintain. Going with an IDNO in this circumstance means that they will maintain that asset for its lifespan and replace it as it goes through the life cycle. You can also look at building out networks to higher demand capacities and hold capacity for future use. So when you're looking at a site that doesn't have the capacity available at this moment in time, let's say it's 500 kVA, you can build a network that is good for 1.5 MVA. You can build that capacity into it with an IDNO, and it allows you to ramp up that capacity as you need it later on, without having to rip out the old infrastructure and put the new infrastructure in. And then, as an ICP fits into this, they are essentially the glue that holds this all together. The liaison between the DNO and the IDNO, but you've also got the same company on rollout, or multiple ICPs in some cases. You can work with the same ICP to deliver the same grid connections with the same teams and the same relationship, and hopefully the same quality on every single site, which ultimately is allowing you to build those long-term relationships, but also allowing you to standardize your approach across the UK. You can also look at mass procurement of items and hopefully looking at a cookie cutter approach. Because you're going with an ICP that is working on all of the sites or all of the rollouts you're working on, you can start looking at reducing your cost of materials because you're buying in bulk, you're buying transformers from different areas, you're buying cables in bulk, and it means that you can really start to build out a standard process for this. And often when saying about the asset value contribution, that also brings down the cost of the projects quite significantly as well. So often it's more competitive than the DNO. So just to summarize the relationship between the three before I start talking about specific projects, the DNO in the way that we work as a business and the way that we're working on national rollouts, the DNO will only do the non-contestable works. The IDNO will adopt the assets that you're looking to build instead of the DNO, and then the ICP will design and build the contestable electricity network, and they can also carry out the on-site works, which can also be a reduction in contractors and multiple contractors working on sites as well. So if I start talking about small EV connections, so these are typically low voltage connections, how does this model work with the three? So if we're looking at a scheme with 1 to 2 DC rapid chargers and you've got capacity on the electricity network, the challenges with these, with multiple rollouts, as we've heard from the panel before, is trying to get all of these chargers in place in a very short timescale. If you've got to work with multiple parties, multiple DNOs, you're going to end up slowing the process down. So generally with the DNO, they will only do the grid connection piece and won't do any of the on-site works. That needs to be picked up by another contractor. So working with an ICP and working with an IDNO, the IDNO will adopt the cable coming in. So you've then got a standardized process. You've got the same cable on every single site in any DNO area across the board. The ICP will also carry out the final connection. So there is zero involvement from the DNO process, apart from having to have them approve the design that the ICP carries out. You've also got a small asset contribution on this, which again is reducing your CAPEX. But it just means that in a project like this, you're able to work with one or multiple ICPs nationally to deliver your rollouts without having to have a major involvement with each DNO. As you scale this up, and this is where there's not enough capacity on the LV network, you're now looking at 11 kV networks. So this is projects where there's multiple rapid chargers, petrol forecourt arrangements, and I've kind of put this into a 2 MVA load perspective. So typically the challenges in these sites are they're already existing sites, there's already infrastructure in place, and space is very, very limited. So talking again about the package substation, talking again about this requirement for additional substations and going over that 1 MVA mark means that you are going to be limited on space. So again, utilizing this model is ultimately saving 1/3 of your footprint on the site. You've managed to get back almost 3 meters on that site just from going with an IDNO adoption. You can drive this even further if the sites are, depending on what the charger arrangement is, and get them into single substations if required. That is a massive reduction on site, especially if you're working on a petrol forecourt or you're working on somewhere where there's existing infrastructure and not a huge amount of space. Again, you've got the OPEX reduction, you've got the capital expenditure reduction. You are reducing the cost of your infrastructure just by going with this solution. If we've scaled this up again even further, and this is now looking at things like large power consumptions, bus depots, where you are now looking at a mixed use of chargers over a huge scale. So you're now looking at going to the 11 kV network is now not suitable. It doesn't have the capacity to be able to take these type of projects. You're now looking at going back into a grid, back into a main supply point to install this infrastructure. And again, you're working on a live site, you're working on phase delivery on this. You may not want all of the power up front, you may want it in multiple stages. So again, looking at a solution where you can standardize this approach across the UK, this makes a real difference. So the benefits with this solution is you are now looking at an IDNO to adopt the entire piece. You're going straight into a primary substation. So you have now got cables being adopted by the IDNO. You've now got all the infrastructure on the site being adopted by the IDNO. So you've now got a standard process at any site that you do. The other benefit with this as well, because you've got you don't have to use the DNO specific design requirements. You can now start looking at using the IDNO requirements across the board. So if you've got, and you're working in a DNO area that requires copper cable, and you've got, for example, on this, a 2-kilometre cable route to put in, that is a huge expenditure on the project. Moving that to a suitably rated aluminium conductor makes a massive reduction in cost. And that's just from this relationship. Again, you've got the operational and capital, CAPEX expenditure. The construction can be the same. You've got the same plinths, the same GRPs. At this point, you are now standardising everything as much as possible, and you can really start to focus on actually delivering the projects, not figuring out what you're trying to do with them. What I'm really trying to summarise with this is these relationships and these partnerships can be utilised and can make the whole rollouts a lot easier. The relationship with the DNO and the relationship with the IDNO and the ICP really does make a difference with this. I've probably run through that very, very quickly, so I'll open the floor up to questions. There's a few of us here, if anyone wants to collar us after this or speak to us at the stand, so please, any questions? I see either good or bad. So,
how can a landlord or a partner who already owns land or a business land, how can they make your job easier or make it themselves to get a quick connection to the site?
Timing, planning up front, not leaving it to the last minute. A lot of it is, grid always seems to be the last thought on everyone's mind. With this, there's always looking at site acquisition, can we get it there? And then the final point is, can we get the power there? And that's usually the stumbling block. If you get early engagement, you can look at areas to go, is there capacity? You can look at the long-term development statements within the UK. If you're looking at hubs, you don't just have to stick in point of connection applications and go, is there capacity available?
I'm not an expert in this.
Can we please go to the microphone? Could you say your name and where you're from, please? Thank you.
Hi, my name's Martin Beaumont. I work for Enertechnos, and we're looking at wireless charging infrastructure. But my question for you on this is, as I understand it, if you put in for a power requirement and there is capacity on the grid, you can get that capacity, and then if you want to increase that capacity later, the DNO has to pay for that upgrade. Whereas if you go straight in with a power requirement that isn't available, you have to pay. I hope that's right. I just wondered how your model fits into that dynamic. Does that make sense?
No, we're trying to understand the question there slightly more.
I'll tell you what, I might ask you afterwards to avoid further embarrassing myself.
No, this one. One sec. Slide them through.
Sorry, I'm Andrew Goodenough from Bristol Airport. It's really about reserving power. So if you apply for power, for an upgrade to your power, it's the charges, even though you're not using that power, would you expect as a user to be paid for that, for that reserve power? So
this is where working with an IDNO, you can use ramping of power. So if you go with the DNO option, you are going to be paying standing charges. You're going to be paying for the usage as well. Whereas if you go with an IDNO solution, you can build that into your offering. You can ramp up the power as your ramping requirements are needed, rather than paying for the standing charges as well as your usage charges from the beginning.
Any more questions? think you've explained this very well.
or really badly.
I was going to just put on Twitter as the one I've learned the most out of, so thank you very much.
No, brilliant.
I'm going to say thank you
Brilliant.
and give people a little bit of a break.